Okay, this is David Zierler, Director of the Caltech Heritage Project. It's Thursday, June 8th, 2023. I am delighted to be here with Professor Frank J. Doyle. Frank, it's great to be with you. Thanks so much for joining me today.
Thank you for having me here.
Frank, to start, would you please tell me your current title and institutional affiliation? And I know because this is a moment of transition in your career, your future title and institutional affiliation.
Happy to, sure. So I am presently the John A. Paulson Dean of the School of Engineering and Applied Sciences at Harvard University, where I am also the John A. and Elizabeth S. Armstrong Professor.
And where are you
And
headed?
yeah, come July 1st, I will have a new title, a new home, new responsibilities. I will become the Provost at Brown University with an appointment in the engineering school as well as an appointment in the medical school.
Frank, tell me about some of the exciting initiatives at Brown and how that might have fed into this becoming a compelling opportunity for you.
Yeah, that's a wonderful place to start. I will say that when I was first contacted, I made the somewhat bold statement to leaders at Brown that I had the best engineering dean's job in the country. I really genuinely believe that. We can get into the details of how I might quantify that. So I was not in the market. I wasn't looking, I wasn't applying for provost positions, but I had a number of conversations with folks there and had a genuine sense of a moment in time, a moment in history, if you will, where there was a tremendous inflection point at Brown, where there was about to be an incredible liftoff in terms of the research agenda, what the campus was trying to accomplish, all the while rooted in the power of a liberal arts institution, which I resonate strongly with from my undergraduate days as well as my current dean days. And so in sum, the future, the opportunities for growth, the opportunities for leadership of an initiative like that became so compelling that I followed through and went through the process and was humbled to be picked to be the next provost.
Frank, I want to ask just to sort of gain an understanding of the overall trajectory of your career. When did academic administration leadership really become a part of what you do? When did that happen in your professional career?
You know, David, I would say that I had become very good at saying no to those kinds of things for a good part of my career. And I think the real immersion into that space, the first sort of taste of administration for me, was running a very large biotech center when I was at UC Santa Barbara. And so I was one of the founding principals of what had been at the time, and I believe is still today, the largest research center on the campus, something called the Institute for Collaborative Biotechnologies. And I'm particularly proud of this one in this context because it's a three campus effort. So UCSB was the headquarters, but Caltech and MIT were partners in the overall grant, the project. And so that was really the beginning of whetting my appetite for getting involved in leadership, getting involved in that particular case, resource management. So having the resources from the Army grant, it was an Army sponsored institute, and being able to bring those resources to my faculty colleagues and enable them to do the amazing things they do in the research world.
Frank, as a dean at Harvard over the past 7 or 8 years, have you been able to retain an active research agenda? Do you teach? Do you have graduate students?
Yeah, so I guess it would be yes, no, yes, if I got the questions in the right order. So I'm proud of the fact that with considerable effort, I was able to maintain virtually the same level of research productivity that I had before the deanship. And I really credit that with the powerful team that moved with me. You might have thought that leaving the Santa Barbara, Mediterranean climate would be a bit of an uphill challenge to move people to Boston, but every single member of my team picked up and moved with us. And so we kept the momentum somewhat unchecked. I found a very receptive environment at Harvard where the faculty and my fellow leaders were supportive of the idea that a dean would be, if you will, in the trenches and experiencing the same challenges, the same rewards of a faculty member doing research. And so really up until the last, really coming out of COVID was the beginning of things slowing down where I had so much to manage on the university side that I began to not be as active in grant writing and things where the group began to shrink a bit.
Frank, looking at your research, it's so multifaceted. There's math, there's biology, there's chemistry, there's engineering, there's computer science. What would be the umbrella discipline where you'd say all the things that you've worked on fit under it in one way or another?
Well, it's interesting. So as dean here at Harvard, I find myself in the unusual position that my field of training, chemical engineering, is not represented as one of our areas at Harvard. So Harvard, we don't have departments. We have what we call areas. We're a very fluid, boundaryless sort of environment. And I like to align myself with nearly each of the individual areas we do have at Harvard. So I wouldn't say that I'm 100% under the bioengineering moniker. That is my faculty home for voting on cases and things like that. But my professional life, I really live in the IEEE. So I align with the electrical engineers and the work they do in feedback controls and automation. The research that we do working with medical doctors and life scientists is really applied mathematics, and we're bringing modeling tools, we're bringing analytical methods. And lately we've been working on embedded systems that you would put directly on a chip in a device. And so I've had computer science PhDs working in my lab. So in many ways, we really have embraced this Harvard approach to boundaryless science and engineering. And my lab really has floated across many different spaces where we needed the expertise to pull in to solve the particular problem at hand.
Frank, I'm sure it remains to be seen, but moving to Brown, do you at least aspire to remain active in research, or as provost, that really might not be feasible?
I think I'm a bit more grounded on this transition in recognizing that I can't think of at the moment, and you may correct me or one of your listeners could correct me offline later. I can't think of too many provosts who are active in research. It is such an all-consuming responsibility when you have that holistic level of oversight for all academic matters on the campus. It's hard to imagine that you could do that and kind of freelance research on the side. And by the way, I didn't fully answer your earlier questions. I'm not teaching. That was a sacrifice I had to make when I came to the job at Harvard. I imagine I might be able to sneak into teach a seminar course or who knows, maybe a course over in chemical engineering or bioengineering. So I hold out hope that I could get back in the classroom. I am an author of a textbook. We are actually beginning to work on the next edition of that. So who knows? Maybe I could get back in the classroom, but the lab, I think, is going to be on pause for a bit.
Frank, in looking over all of your research, what aspects would you say are purely fundamental, basic science, and where have you really been motivated by applications and societal impact?
Yeah, that's a great way to frame things, David, because I think, when I originally got interested in life sciences back in my postdoc days, it was really to try to get at eliciting understanding of how things worked in nature by bringing tools, methodologies, perspectives from engineering. But it really was at advancing our understanding of fundamentals. So in my lab, that took root in problems like circadian rhythms, where we tried to understand at a molecular basis, at a gene regulatory basis, how those circuits in your brain were responsible, gave rise to the remarkable robustness in the mechanisms of timekeeping in your body. And so that was really bringing engineering insights, methodologies, tools, perspectives together with the data and the collaborations with life scientists to advance our understanding of what was going on behind human biological rhythms. I'd say at the translational end of the spectrum, it's really been our work with diabetes, where when we first got into this, I had the occasion to dig up my original proposal from 1994, nearly 30 years ago, where we opined that we thought we could put together a system that would automatically, in a closed loop manner, squirt insulin into the body in an endeavor to keep the blood sugars on target. And at the time, we didn't have the various technological components, sensors, pumps, but we went ahead and we built math models, we worked on the algorithms. So maybe it was applied research in the beginning, and then it became ultimately translational in the last decade, where we did clinical work and eventually put a product in the market.
Have you been involved personally with startups, or have you seen your research take on an afterlife beyond your lab?
Yeah, we had a false start with a startup, so I won't say the name of the company, but it was I would say, a naive approach where a bunch of folks who were scientists and medically oriented had marvelous expertise on that side, but we didn't have somebody who understood the business side. And that was a glaring weakness in our failed first attempt. So we came at this a second time, and this was happening right as I was being recruited to go to Harvard. So I couldn't directly get involved. I knew that as a fledgling dean, I had to really focus on the new institution. So I remained an advisor to the company. But we started a company called Mode AGC, AGC being an acronym for automatic glucose control. And that's the company that wound up getting a license from one of the big pump companies and putting a product to the market beginning of last year, early 2022.
With Boston being a biotech hub, has that really been an asset for your research, for your group?
Oh, it's been huge. Absolutely. Between the companies that we work with in the region, the neighboring schools, I think the power of being at a place like Harvard, where we've got the medical ecosystem. I enjoy an appointment in the division of sleep medicine, and that's where my circadian rhythms collaborations are conducted. But we also have the Joslin diabetes research enterprise here as well. So they became valuable clinical partners working with us to test the different algorithms and modalities we had in human clinical studies.
Frank, I want to ask, I'm sure you're in reflection mode during your deanship at Harvard, a few overall questions about what you've built, what you're leaving behind. But first, to stick with your own research, obviously a theme of your work has been interdisciplinarity, breaking down these boundaries between the disciplines. To what extent did you really promote interdisciplinarity at the School of Engineering and Applied Sciences, just as a way that this is where science and higher education was going?
Yeah, I think that I was lucky to come into Harvard where that was already in the DNA. So from the beginning, the engineering school, it really was effectively a department in the early days of the school, a modest sized unit that just had the engineers under one roof. But even as we grew to, approaching the size of a college or a school at a peer institution, we stayed under a single umbrella. And we had faculty voting as a single body. We had graduate students being recruited to work with faculty across the entirety of the school. So I can't take credit for the Harvard DNA, but I certainly came in, recognized that that was the proverbial secret sauce, and continued to expand that. I would say where I was able to perhaps push it in some new directions was the fact that each of the new graduate degrees that I championed, that I helped sponsor as dean, four of them, three at the master's level and one PhD, each were bigger than engineering. They were, in fact, partners with other Harvard schools. So the first one was a joint degree with the Graduate School of Design, a Master's of Design Engineering. The second one was a joint degree with the Business School. We had this vision that it wasn't a new degree that we wanted to create, but if you will, a melding or partnering of a traditional MS with the MBA so that students got both credentials in that experience. The third joint degree was a Master's of Data Science, and that was bridging across to statistics and the division of science outside of engineering. And then the most recent one we stood up was a PhD in quantum science and engineering, which is a powerful alliance of chemists, physicists, as well as electrical engineers, applied physicists, and computer scientists on my faculty. So really, as a leader on the academic side of things, I really strongly promoted building up of new programs, new degrees that spanned not just disciplines, but spanned schools at Harvard. And I would say the same is true of the, let's call them the marquee, the big research initiatives that we were able to launch during my deanship. They included initiatives in quantum. So we started with something called the Harvard Quantum Initiative. And that has grown now to have a building, to have major sponsorship from big tech companies like AWS, to having faculty lines recruiting, the new PhD program. The other program, which is far more recent, just in the past year and a half, basically, that was a new center in AI. It's the Kempner Institute for Natural and Artificial Intelligence. And that likewise spanned neuroscience, it spanned computer science, applied math, statistics. So really, I would say I came into an environment that already promoted and encouraged breaking down walls, working beyond the silos that we typically have in the academy. But I was able to kind of flourish, if you will, in that environment as an administrative leader by building new programs that further broke down these traditional barriers.
Frank, of course, all of these disciplines have significant national policy, science policy implications. Did you see your role as dean as being particularly responsive? Was it important for you to be part of those national policy conversations?
David, thank you for asking that question because I would say the answer to that question, as I've been doing the reflection that you mentioned earlier, um, points to what I will characterize as one of the most significant things, certainly one of the most impactful and rewarding things that I did during my deanship, which was to establish a working group with the late Secretary Ash Carter, who passed away far too soon this past fall. He and I teamed up as soon as he came back when he left Washington back in 2016. He came back to campus to be on our faculty. He also had an appointment at MIT. And I'll never forget, he showed up in my office one day with a security detail. And he said, Dean Doyle, what can I do for you? And I looked across the table. I said, Secretary Carter, what can I do for you? And it really was a beginning of a profoundly stimulating and rewarding experience and partnership. And so Ash and I pulled together across the Boston ecosystem, thought leaders in policy, in technology, from the private sector, from the academy, from the government. And the idea was we met on a monthly basis with a cadence of fall meetings that sort of unearthed and unpacked very difficult technology problems, and a series of meetings in the spring where we thought about solutions that could be brought to bear. So really over the years that he and I had been doing this, I guess since 2017, just a wealth of really fascinating conversations. And to your point about connecting to policy, we would write up white papers, documents. We had an amazing staff who worked with us out at the Kennedy School. I should have said that Ash's appointment was in the Kennedy School. And so this was another marvelous bridging. As a dean, I think my reputation as I'm leaving is that I was a bridge builder. I was a collaborator. I built across what had traditionally been pretty highly walled silos at Harvard, the individual schools. So Ash and I were really effective, I think, in pulling the Kennedy School together with the engineering school, with a number of kindred souls who joined us from MIT, from the other Boston region universities. And we put together these white papers that were sent to Washington that we hope are having impact with legislators and lawmakers and trying to navigate the very complex space of technology policy.
Frank, as you mentioned, the Paulson School under your leadership grew and diversified dramatically. I want to ask how you manage growth, how you make sure that a particular school or even a university does not get too big too fast. How do you do that?
Yeah, David, it's an interesting question because at a place like Harvard, the undergraduate students are admitted in the first year without a declared concentration, which is Harvard speak for major. So we don't control the undergraduate pipeline. They vote with their feet. And so at the beginning of the sophomore year, they then elect and they pick their fields of study, as we call them, concentrations. So in a way, it's kind of a wild variable, right? We can attempt to model it, we can attempt to predict it. And when I got there, we were already in a growth phase. So if you go back 2007, when the school was founded, we were a mere 5% of the student body of Harvard College, the undergraduates. We are presently approaching 25% of the student body, which is just a remarkable trajectory in 16 years. And I'll say before COVID, I thought we had hit our equilibrium. We began to slow down 17, 18, 19%, 19%, 19%. And I thought, eureka, at last, we have the equilibrium. So to your point, I can do the planning for faculty recruiting and so forth based on a stable undergraduate population. And then lo and behold, COVID happened and it began to creep up again. It was 23, 24, 24. So now we've got what looks like a new settling of sorts. But who knows, with the amazing explosion of interest in computer science and applied mathematics and other parts of engineering, this fraction may still grow. And so the challenge really on managed growth is thinking about what is the teaching and research faculty and staffing that we need to support and enable a program like that. And I've come to really be a firm believer that it's not just things like student faculty ratios that we want to think about. There's so many more pieces of the infrastructure to enable active learning across laboratories and classrooms, the kind of infrastructure you need to run large PhD and postdoc based research endeavors. So there's not a strict kind of formulaic ratio based model of growth here. It's really thinking very creatively in a nimble way about how we cross resource in many ways. So I mentioned that a place like Harvard is very boundaryless, and that plays out in things like teaching. So in applied mathematics, which is the third largest concentration based on sophomore choices, I have 6, 7 faculty who are card-carrying applied math faculty. There's no way you can manage that size of undergraduate cohort with such a tiny faculty count. And the way we pull it off is our other faculty all pitch in and contribute to the teaching mission. So the applied mathematicians are supported by computer science, by environmental engineering, by applied physics. So I would say that's the good and bad of having a place that's boundaryless, is you don't have to then be siloed and say, okay, let's have this ratio student to faculty in CS, this ratio in EE, this ratio in mechanical. You can think about the larger enterprise and where we derive synergies and efficiencies and grow accordingly. And that's where I think we have grown in a healthy way as a faculty. I think we're still subscale in terms of the size of the student body, the master's students, the PhD students, the undergraduates. So we still need to continue to grow, but that'll be the remit of the successor to me here at Harvard.
With all of this growth, of course, requires faculty recruitment. What have you learned about recruiting the best and retaining the best?
Yeah, that's a great point. I think both recruiting and retaining, I could almost think about as two sides of the same coin, in the sense of what I have found to be the most compelling draw to pull people in and to have them stay is to create the right ecosystem. So as a dean, I'm not looking to recruit an individual who will go lock themselves up in their laboratory and just work by themselves with their students and teach their boutique course. I really want to bring somebody in who's going to be a part of a collaborative team. And not everybody joins big, 10, 12 PI type project teams, but somebody who is going to come in and collaborate in the classroom, somebody who will come in and cross-mentor, be on PhD committees. And so selling to people like that, the power of an ecosystem where we have core facilities, we have shared labs, we have resources that benefit the community, becomes the way that I can then invest as dean, as opposed to just thinking about investing in the single PI. So obviously there's a balance. So single PIs need to be supported. They'll get their startup packages. But really, I think the secret sauce is creating the ecosystem. And in the right ecosystem, then you have centers and institutes that flourish. And I've given you a couple examples already where we were able to do that. And they'll serve as magnets to not only pull in, but to retain that next wave of faculty who will play in that sandbox.
Frank, in reviewing the motivations and desires of undergraduates and graduate students, the kinds of things that they want to go into, graduate school, industry, what opportunities have you had to shape the curriculum and structure of the Paulson School to be responsive to those interests?
Yeah, I think I'll share with you two thoughts there. So one is, if you'll permit, I'll reframe that a little bit and put it as a question that probably the number one question I get asked as dean, which is, so my kid got into Stanford, MIT, Caltech, Harvard. Why should my kid come to Harvard? Seems like a small program. Maybe if we take Caltech out of there, but compared to the MIT and the Stanfords, we are a small size. What's the advantage of that? And I will argue that size is indeed an advantage, because we have a very intensive hands-on learning experience. And that's been a part of the program that I've been able to invest in and grow, where now a huge fraction of our courses have an active learning component, have a hands-on component, where the kids are either being immersed in the makerspace, or their specialty labs are being supported by a staff that we have built that enable this active learning mode. So you can't do that with a large scale program. You just can't provide that sort of hands-on experience. So I would say that's one of the first advantages. The other two steer a little bit away from your original question, but I'll share with you nonetheless. And that is, I think the ecosystem at Harvard is really unparalleled. I think the fact that we have the medical school, we have the law school, business school, where our students can really interact and collaborate across these activities means they can do their senior thesis in bioengineering with a medical doctor in the med school. They could work on computer science, ethics, or policy issues with an expert at the law school or the Kennedy School. So that's another advantage. And then the last one is one we've already talked about. We really are boundaryless here. We don't have departments. And that creates this, I think, uniquely boundaryless experience where students don't feel like they are narrowly trained in one subset of engineering, but they've been exposed to the experience, the wealth of opportunity that comes when you look beyond boundaries and you reach across and you collaborate with other fields. So really, that's where we've been investing in the academic program in a way that I think, even with the growth, we've been able to keep up with that and provide this very interactive, very intensive active learning experience.
Another major initiative across higher education, especially in the past 5 years, has been enhancing diversity and inclusivity in academia. Leading the Paulson School, what opportunities have you had to promote these values at Harvard?
Yeah, David, that's a great point. We were, I'm very proud to say, our team pulled together and were one of the first entities within Harvard to put together a formal DIB plan. So we are actually in the fourth year of a 5-year plan. My successor will get to write the next 5-year chapter of that. And this came partly out of a convening of my cabinet, where I have an advisory cabinet with leaders in industry, alums of the program, who really just work with me closely to provide feedback and give me guidance on the challenges and opportunities ahead in the school. And I put the question to them for one of our very first sessions. Help us think about how we can be a more excellent program, a more inclusive, a more diverse program, and have this wealth of suggestions. And some of them were prefaced with comments like, well, we can do this in the private sector. I don't know if you could do this in the academy. And honestly, I took it as a challenge. One example I'll never forget, Nate Blacharczyk, who founder of Airbnb, one of the co-founders, graduate of our program, was hosting us for the cabinet meeting. He said, Frank, I can reward my managers for hiring diverse groups with things like bonuses and so forth. I don't think you could pull that off in the academy. And I said, the bonus system is completely at the discretion of the dean. Of course I could pull that off. And so the very next year, I advertised it. I talked to the faculty and I said I would be using the bonus pool that year to focus on successful activities in diversity, inclusion, and belonging. And I said, before too many people sort of react to that, let me make clear that you can bring DIB practices into teaching. You can bring practices into how you run your research lab. You can bring those practices into mentoring, into outside activities. They're a wide array. And we put together a deck of examples. It had to be 10 or 15 pages, just to give faculty an idea that there's a full roadmap out there. And you can find your way to how you could contribute and engage here. And right away, the faculty reacted quite positively to this. And it was a challenge for me just to pick some of the highlights to be able to reward that year for DIB activities. But it then became something that cross-pollinated at Harvard. So I did this in the engineering school that year. And then the broader Faculty of Arts and Sciences, which is the main body, the corpus of Harvard faculty, took up the idea of putting a diversity question in the annual report in their annual review. And so this spread and became a virtuous sort of cycle that expanded on the campus. So I was pleased that we had the right team, not only this external advisory team, but my internal team that recognized the prioritization of what one can achieve when one has an excellent, diverse student body, faculty body, staff body. And we really rolled up our sleeves and put together this 5-year plan. I think we had something like 42 discrete items of action. And proud to say we've knocked off something like 36 of them at this point and are making good headway on the remaining 6. So it took a community, it took changing the mindset, really building a culture of recognizing why this was important.
Well, Frank, let's go back now and develop your personal narrative. Even before we get to undergraduate, growing up, did you have anyone in the family that came from an engineering or a science background? Was that sort of part of your childhood?
Well, so the joke was that Thanksgiving conversations got a little nerdy between my father, my brother, and I. All 3 of us are chemical engineers.
Oh, okay. Family business.
There's a little bit of a family business, although we've each taken it in very different directions. So our father is a chemical engineer. He did work in the on the industrial side. So he started his career with Stauffer, which was a chemical company. They manufactured polyvinyl chloride and then used that as a base for a wide array of products. He eventually rose to become the manager. He ran the entire plant that was producing this in Delaware. And then he had sort of a second wave of his career where he was working in a refinery. And likewise there, he rose through the management ranks and became the IT manager for the refinery. So he ran automation controls for this entire, it was a Getty refinery at the time, became Texaco, and I think it's now Saudi Aramco. So Dad was an engineer. Dad certainly was a bit of an influence. I'm the eldest of 5, and so I did take up the family trade, although I will say that I really wrestled hard with considering English was my second calling. I had a marvelous English teacher in high school, Barbara Riley, and she had convinced me just the excitement, the allure of tearing apart a complex poem, of unraveling the meaning in a deep novel. And I really went into Princeton kind of wavering between those choices. And of course, a little bit of a bias on the home front there, hearing from Dad on what a chemical engineer could do, helped sort of steer me in that direction. And then 7 years later, my younger brother, Pat, also took up the mantle, and he specializes more in microfluidics and transport. But like me, he's a faculty member across town at, there's a small tech school that has 3 letters in the name on the other side of Cambridge that he works at.
Frank, as an undergraduate, is that when you realized that engineers could be professors? Did you think from your dad growing up that it was purely an industrial kind of vocation?
Oh, I would say there was no hint in my mind of pursuing the professorial ranks until well into graduate school. So coming out of undergrad, I worked in industry. I worked for DuPont, which was the company in the backyard in Delaware growing up. Did my internships there. I knew I liked research. But I thought I would do applied industrial research. So when I set out to do my PhD, it was really with an eye to getting that experience to launch into an R&D type position in industry. I interviewed for a couple industry roles coming out of undergraduate, and I found that the things that I was drawn to, particularly R&D, were out of reach with only a bachelor's degree. And so that was really the main motivation for me to continue my studies, was to think about positioning myself for applied industrial research.
Frank, at Princeton, were there any faculty members who you would consider mentors, or were there any classes that, looking back, were really formative in your development?
Yeah, I would say on the mentor front, my thesis advisor, Roy Jackson, was tremendous. He taught the kinetics class. He was one of the most influential instructors. I think eventually when I did get the bug and decide I wanted to be a faculty member, I tried to channel the amazing experience I had of sitting in a classroom learning from Roy Jackson to what I might aspire to become in teaching. But Roy was a terrific mentor. He's a wonderful human being. We still swap Christmas cards. It was really an amazing experience working with Roy. I think class-wise, as I reflect back on it now, I think there was an experience in what most places would call the unit ops lab. So the place where you do some hands-on work, where we did a dye experiment where you were titrating how much dye you put into a stirred tank with a spectrophotometer. So you were trying to control how much dye would get you the right color reading on the device. And it, in hindsight now, it was the beginning of thinking about control. It's a dynamic experiment. It was doing mixing and trying to get to the right target, which is what I eventually wound up pursuing in graduate school. I was intrigued enough with that I took the controls class at Princeton, which was one of the very few schools in the country where controls was not required to get a chemical engineering degree. It was an elective, and it was largely a course taken by graduate students. And so I was a bit of an outlier in there, but really got a taste of something, even though, as I've joked with him later, Professor Sundaresan was not a controls expert. He was clearly just assigned to cover the class. And yet there really was something in that content that was inspiring and led me to then think about graduate school specifically in the field of controls.
Frank, what did you do during the summers as an undergraduate? Did you work back home? Did you stay on campus?
I went back home, and a couple of summers I worked for a contractor. The name of the company, again, was prophetic. It was Process Controls Incorporated, PCI, but they were pipe fitters. They were laying the instrumentation in the DuPont plants and the other plants in the region. And really, I was a glorified laborer. So I wasn't union. I wasn't actually doing pipe fitting. It was really almost like working construction, but within a chemical plant. So I was getting experience. I was, tripping over and moving control valves long before I understood actually what a control valve was and its purpose in automating a chemical plant. So I did that my summers, and then eventually, as I began to build a little bit of knowledge, I became capable of working for DuPont. And so the last couple of summers, I actually worked at DuPont, lived at home, and drove into the facility.
To clarify, did you graduate and pursue industry jobs and only then realize that you wanted to go to graduate school, or did you do graduate school right away?
I was one of these incredibly indecisive individuals at that stage, as with other stages of my life. But at that particular stage, boy, I applied to business school. I applied to nuclear engineering grad school. I applied to chemi grad school. I interviewed with companies. I really covered the waterfront because I really just wasn't quite sure of what it was I wanted to do. And then I applied for these international opportunities, which is where I eventually started the next step, because I just wanted to explore and figure out what resonated. And I think I pretty quickly winnowed the field down. I decided nuclear was too narrowing. I like nuclear engineering a lot, but chemical engineering is a very broad discipline. It really covers virtually all aspects of physical sciences and engineering, and life sciences, as it turns out. But I really did, explore the waterfront before I then decided I was going to do this international experience, and after that, wind up in Pasadena.
How did Cambridge get on your radar? How did you learn about the program?
I think I was in the office at Princeton where they had various paraphernalia about scholarships, and tripped across this one for the Churchill Fellowship, and thought, this could be an interesting fit. So I went back and I spoke with my mentor, with Roy Jackson, who had been Cambridge educated. And he was singing the praises, absolutely singing the praises of the opportunity to be in Cambridge, to learn in that environment. And there really was this, in my mind, was shaping up a plan that would be the best of both worlds, where I could get into a PhD program here in the States, but defer for a year and go abroad for this 1 year, not just traveling abroad and, experiencing international life, but really studying while being immersed in another culture and learning. And so Roy convinced me that would be kind of the best of both. I applied. I was fortunate enough to be picked for a Churchill Fellowship. At the same time, I got into Caltech and a handful of other graduate programs, and then had to begin what turned out to be a painful conversation of, eliciting a deferral. And without naming names, I'll simply say there was one stubborn faculty member at Caltech who said, you could go do a postdoc at Cambridge. Don't waste your time now. Come here, come right to Caltech for your PhD. And I went back to Roy, and I remember saying to him, "Oh man, I'm crushed. I want to do Cambridge, then Caltech." And Roy said, "Oh, it's a recruiting bluff. Call their bluff." And I did. And I said, "Okay, well, I guess I'll have to reapply next year and see how things go." And the person said, "Oh, no, it's okay. We'll defer for a year, and you can come here after you do your year in Cambridge." So it was interesting recruiting tactic that I must say I've never practiced myself. But in any event, I was off to England for the next chapter in my educational journey.
Now, the program at Cambridge, was it explicitly a terminal master's? Could you have stayed on for the doctorate if you wanted to?
I could have. In fact, that was a really intriguing part of the whole proposition, because at Cambridge, that entry into the graduate program was effectively skipping what is the first year of the graduate program here in the States. Mm-hmm. So Cambridge in the last year of the undergraduate, it's almost like the master's training that we have here. And so had I stayed at Cambridge, it would have been a 3-year PhD. And that fellowship did offer me either the PhD track or to do the 1 year, it's called a CPGS, effectively a master's. And it was tempting because, of course, I was facing 5 years back at Caltech. So it would have been 1 in Cambridge plus 5 at Caltech, 6 years, or 3 years just at Cambridge. And I think I really thought hard about the fact that I had cut out a crucial part of the educational experience, that foundational first year in the US or final year in the English system. And furthermore, that if I wanted to land a job in the States, I felt, and I don't think it's true today, but back at that time, it did make more sense to get your degree in the States and then get recruited to a US-based company.
Frank, just from a cultural perspective, what was the value of that year living in England for you?
Oh, it was beyond compare, David. And I know we're in a Caltech context here, but I'll say that of the 10 years that I spent between my undergraduate, my master's, my PhD, that was by far and away the most rewarding year, just to be immersed overseas. Obviously, it was the same language, so I didn't have the language kind of cultural opportunity. But it was a year where all kinds of interesting international things were happening that had such different perspectives on the other side of the ocean. For example, that was the year that Reagan bombed Libya. So Gaddafi was in power, bad things were happening there. In the US, Reagan was at an all-time high on popularity for having done that. In Europe, he was uniformly denounced for basically aggravating a war in the Mediterranean, which would disrupt trade and so much of life in Europe. And so to experience from the other side of the ocean that different perspective on world events, I think to me was transformative in opening up my eyes to appreciate there's something. I knew I had a bit of a sheltered life in Delaware, a tiny state, but growing up in the US. There was a much bigger cultural, geopolitical landscape that I was exposed to and began to really appreciate. But I would also say that even when it came to sports and other activities, some of the Americans right away ran to the basketball courts or, would throw a football around on the fields. And I really resisted that and only did things that I thought were unique to my experience in England. So I played cricket. I jumped in a cruise shell and I rowed for the first time ever. I played tennis on grass courts, which were just available in the college for kids, who wanted to just play a pickup game. Over here in the States, you can only do that on at a premier country club or something. So I think all the way around, I really tried to make it a year of embracing new things, new ideas, new connections. And to this day, some of my dearest, closest friends from university days were from that year in England.
Did you have an opportunity to backpack around the continent?
Well, that's another funny story, because what I did instead of backpacking around the continent is I went across to Ireland. So my roots, as you might guess from my last name, are Irish. I'm about 75% Irish. And it's actually on my mother's side that my grandparents emigrated. So my mother's cousins were still living in Ireland. and their children being my second cousins, we got to know each other. So instead of backpacking around Ireland, I would take a ferry across, and it was in the north of Ireland that my relatives lived. So for context, we're talking mid 80s. So there was this thing called the Troubles happening in the mid 80s. And here was this naive American going right into the thick of things, not far from Derry. And I'm from a Catholic family. My relatives are Catholic, living in the north. It was a very, let's say, interesting time. It's the only time in my life that I've had a small caliber machine gun pointed directly at me in a car. I was crossing a checkpoint in Northern Ireland. So no, my advisor at Cambridge used to make fun of me because he said, you Americans, you Yanks, you're supposed to go, wander the continent. What are you doing going to Northern Ireland for a holiday? It's ridiculous.
Frank, born and raised on the East Coast, I'm wondering if Caltech loomed large in your life at all. Had you heard of it? Were you aware of names like Linus Pauling and Richard Feynman? Or was that all new to you for graduate school?
A lot of that, I have to say, was new to me. I had put together a list. I applied to 5 graduate programs in the States. And I have to say, I did what I tell my own advisees not to do today, which is I began to think in a very specialized way. And I applied to 5 programs that all had strong process control faculty within the chemical engineering program.
Applying to faculty as opposed to program.
Yeah. Exactly. And I tell my students, my advisees, don't do that. Keep your options open. Go in open-minded. You don't know what that subfield really is.
Or the personality with the faculty member.
Exactly. But I really had narrowed the field to doing a process control PhD. I had 5 really powerful schools. And in those days, it wasn't these weekend convenings that we do for graduate recruiting. It was you set up a personalized itinerary. So I arranged with these 5 schools to do one single trip across country in my spring break week, and literally went from Boston to Houston to Madison to Berkeley down to Pasadena. It was the last stop. One might say I saved the best for last. It was magnificent weather. I was really blown away with the folks I met in the chemical engineering department. I had friends from Princeton who had gone on to that program at Caltech, so I actually knew some people there. And all the way around was so impressed with the setting of the campus, that kind of intimate feel. It wasn't a big sprawling state campus like a couple of the other places I was looking at. It did have that intimate feel. It had an intellectual, just, powerhouse sense as well, that I knew that for that period of my academic studies, this would be a really immersive, intense experience. And I have to say, something that I don't think I could, with any degree of accuracy, say that I pinpointed at the time, but many people have pointed out to me in hindsight, was that the sort of focus on undergraduate versus graduate programs was clearly skewed toward the undergraduates at Princeton. Mm-hmm. But at the time I was at Caltech, there was definitely a skew favoring the graduate students. Now, some of that may have balanced or reset in the days since, but really I left an undergraduate strong campus for my undergraduate degree to go to a PhD strong campus for my graduate degree. And maybe I just had a sense of that without really thinking too analytically about ratios.
What do you think the year in Cambridge did for your preparation for graduate school? In what ways did it supercharge or advance what you had come to Caltech to do?
I think it was a mix of things. It certainly, there was a bit of a challenge in the sense that my core training, my junior and senior year courses in things like kinetics and transport and thermodynamics were now 1 year removed. So I didn't have the same momentum as somebody else coming out right out of senior year with everything fresh. So coming into things like the qualifiers, I felt that at some level put me at a little bit of a disadvantage because I had been further removed from the material. But I would say 2 things in particular about the experience in Cambridge really did prepare me. The first is the work I did there was actually an experimental project. And I enjoyed that. It was rewarding, but I also realized that was not what I was most excited about. I was more of a computational modeler, analysis person. So that part of the project, I especially enjoyed back in Cambridge. But the hands-on part, I just didn't have the patience for some of that. It would take forever to fabricate components, and some of the data collection was tedious. And with profound respect for my colleagues who do experimental work, it just wasn't for me. So I at least could eliminate that as what I would focus on in my eventual PhD studies. But the other part that I think is profound about the English system and very different from the American is how much it instills self-reliance. So, for example, there weren't homeworks assigned throughout the semester, throughout the term. In England, you had to self-motivate. There would be problems, there would be material you could access, but you didn't have the little incremental assessments that we do here in the States. And then it all becomes, if you will, sink or swim when you take the exam for the degree at the end of the year. So that really motivates you to go to help sessions, to attend tutorials, to really stay on top of things. And at the end of the day, that's really what the PhD is all about. It's not a lot of hand holding. It really is encouraging independence, encouraging you to think and explore. And those were skills I think I began to lay down some foundations in England because of the very nature of the English system.
Now, once you got your bearings at Caltech, the program or the area of strength or even the faculty member that you were attracted to, did that remain on track, or did you change course at Caltech?
It was so it became interesting. If I have my numbers right, there were 12 of us that came in the cohort that were doing chemical engineering PhDs. And I think the faculty at the time were either 8 or 10 faculty, including some really just superstar, prominent individuals. Frances Arnold was just beginning her career at Caltech, for example. So this person that I wanted to work with, Manfred Merari, he turned out that 5 of the 12 kids put him as their first choice. I mean, normally in these PhD matchmaking, there's a little more distribution across the faculty. So here's one faculty member who did not run a huge group. So 5 in a given year would have been abnormal, certainly. 5 of us put him down. I think in the end, he took 4 of us, and the 5th found an alternate. Number 2 was a good match. So I stayed the course. I absolutely came in and stuck with it, even though it looked daunting that first year with too many people expressing interest. But eventually landed in that lab, had an amazing experience, and still to this day stay very close to Manfred. We had a drink together in Philadelphia a few weeks ago just to kind of catch up on where things were going with me. So he has moved. He went from Caltech to ETH, and now he's at Penn. But I stuck with it and haven't thought twice about it since that experience. It was the right thing for me, and maybe I was just odd that I had specialized and narrowed my thinking coming out of undergraduate, despite what I tell my mentees. But it served me well.
Tell me about Manfred's work. What is he known for?
So Manfred is one of the giants in taking what is known as model-based strategies to apply to control. So he literally wrote the book on something called IMC, internal model control. He was one of the powerhouses behind something called model predictive control, which is an algorithm in which you embed your understanding, represented in mathematical form, of the underlying process. And you use that to make forecasts into the future of how the system will react if you modify, if you adjust, if you change the inputs coming in. And you can turn that into a big programming problem where now you say, find the optimal sequence for me to be able to keep this variable at that target, or this variable having that trend. And this was something that was coming out of industry. It was an unusual example of technology that started in industry, and then the academics got their hands on it and sort of codified it, robustified it, made it a stronger package. But really the genesis, the inspiration, came out of experiences that were happening in refineries in Texas at the time. where the germ of the idea came out from industry. But Manfred and a couple other labs really were pioneering and moving forward a foundation for understanding that, for analyzing that, for guaranteeing certain performance, and then applying that across an array of areas. And in my case, I was looking at fairly traditional chemical engineering application. We had a methanation reactor actually in the lab. And as I mentioned earlier, I learned my lesson that I'm not an experimentalist. So I use data and math models to try to design algorithms and controllers for.
You mentioned your attraction to modeling, this being the late 1980s. What was the state of the art with computation in those days?
Yeah, interesting times, certainly. We had a Microvax computer, was the computer in the lab. And to this day, I believe that the reason I am a morning person is I started going into the lab very, very early so I could get cycles on that computer. Most other guys were hanging out through the afternoon into the evening. And I realized, if I could get in here really early, nobody was running jobs on the system and I could get my jobs run efficiently. But it was Fortran code, very sort of basic things. And we were just beginning to experience MATLAB coming in as sort of a toolkit, as a macro environment. So there weren't that many MATLAB toolkits out yet, but there was one on control systems. And so it was, just the beginning of using macro languages like MATLAB. Mathematica was just coming in, I think, as I was finishing my PhD. So it was not anywhere near as exciting as we have today with the tools and the array of things that we can work on. But it powered us to be able to build sophisticated models of complex chemical reaction systems and evaluate control methodologies.
Tell me the process for developing your thesis research.
Yeah, that was as often is the case. There's sort of twists and turns. So I mentioned that Manfred's lab was known for model predictive control, and several of the students from my cohort got involved in that. I had a very different kind of leaning. So I got excited about this idea of nonlinearity. So most of what people were working on in process control at the time was linear methods. You make a first order approximation of a system. And as long as you stay in the neighborhood where you made that approximation, that's a good mapping of your system. I was more fascinated by what happens when those linear methods fail. What happens when you have wide excursions, or if you have something that is so pathologically nonlinear, the intrinsic chemical kinetics or the properties of the reactor are so nonlinear, what do you have to do then? So I became a little bit of an outlier in the group. The core of the group, most of the group, were working on these linear-based methods and in particular model predictive control. And I got very excited and interested in thinking about nonlinear algorithms. I think what was motivating me all along was that everything in the world was nonlinear. We didn't know of anything that was truly a linear beast. And so linear was an approximation. And I wanted to find out when that failed, when it really did require that whether you think of this as orders in an expansion, that you go to second and third and fourth order, or whether you think about actually trying to grab the nonlinearity and twist it to work to your advantage in an algorithm. And that led me into looking at things like feedback linearization, which was a method for saying, okay, I can recast my problem in a coordinate system where in the new coordinate system, behaviors are linear. And we know what to do with linear systems. We have decades of experience. But now when I map back to the original coordinate system, I now have a nonlinear algorithm because that mapping is nonlinear. So I take tried and true methods in the linear space and fold them through a nonlinear mapping back into the real world, into the physical space. And I have created a nonlinear algorithm that gives me somewhat provable linear characteristics.
What was Manfred's style like as a mentor? Was he hands-on? Was he hands-off?
Very hands-on, very hands-on. We had lots of regular meetings. He would show up in the labs, very actively engaged in the mentoring.
And your fellow graduate students, were they all more or less working in the same area, or you were really off on your own with this topic?
I think several of them were clustered around this topic of model predictive control. Um, I was really at the time for several years the only one who was looking at these nonlinear methods and feedback linearization. Eventually, there was another student who came in when I was near the end of my studies who was going to pick this up and continue with it. But it really was, for me, it was actually quite enjoyable. I will say now on reflection, I'm an intrinsically collaborative scientist today. All of my projects are, multiple PIs, big collections of students and postdocs. It was a strange period in my scientific career where I really was a bit of a lone ranger and enjoyed that and enjoyed sort of tinkering and pushing. And as a chemical engineer, I was really reading the double E literature and the math literature. They were the folks who were really advancing some of these things, as well as mechanical engineering, flight control systems. They were applying these methodologies as well. So it was forcing me to stray a little bit from chemical engineering. And maybe that was the beginning of me thinking about getting beyond traditional barriers and boundaries. But for me, it was quite enjoyable to do that.
You mentioned that a lot of these tools were coming from industry into academia. Did you see your thesis research as responsive to any particular industrial applications? Did the road go back that way?
So for the work I was doing, which broadly was under this moniker of feedback linearization, so bending the problem into linear space, solving it, and then folding it back. Um, Flight controls, robotics, power systems. There were a number of industry sectors that were using these methods. Interestingly, chemical engineering was not. And I think, if I reflect back on it now, many of the chemical engineering systems were largely running in quasi-steady state. So you had an operating level. You were making a grade of polymer at DuPont, and you just ran the reactor at that set point. And so little deviations around that set point could be modeled with reasonable accuracy by a linear system. And so they didn't need the complexity that would be required in putting a nonlinear controller onto the system. So I would say no. At the time I was doing my work, I think there was more curiosity from industry, but not the adoption that you were seeing from these other methodologies.
Mentioning robotics and flight controls, I'm curious if JPL was an asset for your work at all, if they were doing anything relevant for you in those years.
You know, I remember going to workshops at JPL, NASA Ames, up on the Berkeley campus even. So the West Coast had a wealth of activity, largely in robotics and aerospace, around some of the control methodologies that I was studying. And so I would take advantage of that. And that was a powerful part of being in the locale, being at Caltech, as opposed to, say, being somewhere else in the country.
Looking back at your thesis, what were some of your principal contributions and conclusions?
Ah, hmm. I think we. I haven't thought about that in a while because as will unravel soon, I took a major pivot in my
Yeah.
postdoc. But I'm quite proud of the fact that we pushed the assessment of nonlinearity. So let me explain. One might think you have linear methods, we'll try it and see if they fail. You might also think, I'm a nonlinear control person. The whole world's nonlinear, so everything should be controlled using my methodology. The knee jerk is to go right to the complex solution. I think part of what I was very proud of, and it was literally either the last chapter or the last paper that we got from the work, was putting together a quantifiable measure to be able to think about how nonlinear is a nonlinear system. Does it really necessitate nonlinear controls? I just gave you the example of the polymer reactor, which if you run it at steady state and there are small deviations around that target, you probably could get a reasonable linear methodology to work for that system. So when is it that you begin to push such exotic behavior that you really need, or such extreme performance demands that you really need a more sophisticated algorithm to be able to do that? So I think posing the question of when you need the tool, for me, was more impactful than merely just having the tool to apply.
Besides Manfred, who else was on your thesis committee?
So that's another interesting part of the story here, which really ties into why uh, being a professor became the attractor for me. So my co-advisor was a gentleman named John Doyle, who's still on the faculty at Caltech, and we are not related, at least not for a number of generations. We can each count back to Ireland. But John came along and was really interested in the work, the nonlinear control work, and took an interest, began to collaborate. So I would have meetings with John and I would have meetings with Manfred. And the relationship with John, they had very different styles. So John's, and I believe probably still to this day, because I think he's the same person. You would go in there and it would just be like sipping water from a fire hose. He would just go on and brainstorm and go all over the place with, lots of really insightful ideas. And, it was before the day of the iPhone, but if I were going to meet with him now as a student, I'd secretly flip on the record button just so I could capture all the ideas because they were coming fast and furious in real time. And you would go out of there and you were lucky if you could sort of get back to the office and scribble down 2 or 3 things that you were going to go chase. So John really was an amazing kind of idea generator, very provocative thinker. Manfred was much more of a methods and methodology kind of person. So it was a marvelous yin and yang kind of thing to think about how to attack the problems I was looking at. But John's the one who eventually gave me a taste of what became then the strong appetite for teaching. So John was slated to offer a course in nonlinear controls. So it was using geometric methods, which are these methods of doing linearization. And he said, Frank, this is really what you're working on in your thesis. How about you do a guest lecture? Why don't you do the opening lecture? So I did. And he said, hey, that was pretty good. You want to do another lecture? And so I did. And next thing, I'm teaching the whole course as a graduate student. And so, this was a graduate level course. So it was appropriate. I think it wasn't me taking over a core required undergrad class or something like that. And I really enjoyed it. The idea of preparing content and translating it back in a way that you could gauge the understanding in the audience, to me, was something that I found rewarding. To be able to get nods in the audience and see people, comprehend the complex ideas I was trying to convey was very different from, let's say, giving a technical talk at a meeting. For me, that experience was. And I think it was my first taste of teaching that began to turn the wheels in my head of, maybe I want to be a professor. Mm-hmm. Maybe this applied industry is nice, but if I were a professor, I could work with industry, but I could do this teaching thing, which really, for me, was quite rewarding. I really, really enjoyed that experience.
Frank, you mentioned earlier it wasn't until your postdoc that you started thinking about the life sciences. I'm curious, given your affiliation with the systems biology program at Harvard, if you were aware of what Lee Hood was doing. This was really the height of his lab at Caltech, if you ever crossed paths with him.
Lee and I eventually crossed paths and collaborated much, much later. And we've kind of joked about the fact that, there would have been this near crossing that didn't happen because really I was, I'm going to say, oblivious of interesting problems in the life sciences while I was a graduate student. I hadn't taken biology in undergraduate, definitely didn't take anything in graduate school. And so that was a universe that I had not even been, intrigued by at that point. So it wasn't until the postdoc experience that I made that pivot.
Now, this self-discovery, this love of teaching, this thought that you might pursue a professor's life, did that influence the kinds of postdoc opportunities you pursued?
It did, certainly, because by that point I was thinking the next thing after this springboard would be trying to land a faculty job. And I will say it was a slightly different time then than it is now, where you really could basically get a faculty position right out of grad school, no postdoc needed. In chemical engineering, it was rare that people were doing postdocs, different from, say, the life sciences. But I went out there and I actually applied I did the same thing I did undergraduate. I applied for industrial jobs just to cover the bases. I applied for postdocs and I applied for faculty positions. And I had, in a way, a wealth of wonderful, wonderful opportunities where multiple postdoc invitations were extended to me. And I got multiple faculty offers at the same time. So I could basically coordinate them and say, all right, I'm going to accept as I did at Purdue University, but I'm going to do a year's postdoc and as it turned out, DuPont was the place that made sense. And it really was. They were coordinated in the sense of the DuPont experience I knew, different from an academic postdoc, was going to give me connections in industry that I could build on as a faculty member and use to stir up collaborations and funding and things like that. Purdue was a very applied place, and I knew that having strong industry ties would serve me well in a faculty role at a campus like Purdue. So there was a very sort of coordinated decision-making process to kind of land concurrently with the idea that, okay, here's the postdoc, there's the faculty position, and kind of got things sewn up neatly at the end of my PhD.
Professionally and personally, going to DuPont, did it feel like you were going home?
It did. It really did. It was some of the familiar faces that I knew. And honestly, the DuPont thing, to be accurate, was a little bit of almost happenstance in the sense that I applied for a full job with that group, the controls group at DuPont. And I remember a very candid conversation with the manager, a wonderful, wonderful gentleman and mentor, Dave Smith, who passed away many years ago. And Dave called me up and said, Frank, I'm not sure if I'm going to be able to offer a full-time position this cycle. I don't have, the line, it turns out. He said, but there's a possibility that we could do something different. And I said, well, Dave, let me tell you, I really want to be a professor. So I interviewed in industry, but just to test the water, I really want to be a professor. And he said, Frank, I can hire you for a year as a visiting scientist. Come do that as a postdoc, and then you could start your professor position. And so it really was almost handcrafted for me by Dave Smith to be this amazing experience. It turned out that there were about half a dozen people that followed me at DuPont in subsequent years doing similar things. But I was the first of these so-called industry postdocs or visiting scientists who had a chance to, be immersed in the company, get exposed to their problems. And really, I think there was a very forward-looking mentality at DuPont that we weren't saving them money that year by optimizing a process or, helping them with anything related to the bottom line. They were exposing us to their problems. So we went out to the academy and trained students who could come back, be hired, and our research could help them with their problems. So it was really forward-thinking idea.
Tell me about that year at DuPont. What did you work on?
It was very interesting. I had 3 different projects. So I went in expecting to get dirt under my fingernails to have a real plant project. And indeed I did. I had a polymer reactor separator system in Houston, in LaPorte, Texas, that I was helping support the real-time control design for this unit operation. I had a theory sort of project. There were some engineers at DuPont interested in nonlinear control and wanting to do more of the series approach. So I mentioned you could have a first order approximation. That's easy linear math. Second, third, fourth. So we worked on something called Volterra series, which were a way of expanding a nonlinear dynamic system to get those higher order effects in a sequential manner. So we did some more theoretical work with folks in the research center there. And then somebody pulled me aside early in the time there, one of my mentors, the late Babatunde Ogunnaike, and he said, Frank, we've got this small group of us that are trying something a little out there. We're looking at nature for ideas, for inspiration, with an understanding that Mother Nature has had much longer to optimize and fine-tune circuits and systems and algorithms. What if we could learn from them and apply that in the chemical plant automation context? And I said, sounds fascinating. And so I got recruited to be a postdoc working in this lab with neuroscientists, chemical engineers, electrical engineers, to try to unravel what Mother Nature was doing. And the particular problem was beat-to-beat control of blood pressure, something called the baroreceptor vagal reflex. So we modeled this, we simulated this, we analyzed this, and then we tried to reverse engineer it and come up with an engineering analog to Mother Nature's controller.
When you joined the faculty at Purdue, How did that year at DuPont affect how you wanted to set up your research operation as an assistant professor?
It was in a multitude of ways. So certainly, I had the advantage of these deep ties to DuPont collaborations and sponsored research that happened from that. So they supported my lab with grant funding. They created summer opportunities for my students. So I had my PhD students do internships during the PhD, which I would say was not completely conventional, but became a practice amongst many labs in the systems area to have students do internships during their doctoral studies. And importantly, it had me literally from day one create basically two halves would be too strong a word, but two thrusts within my lab. One thrust that was more chemical engineering, process control oriented, and another thrust, which we didn't call it this at the time, but it was systems biology. And we were looking at biological systems and bringing these tools from modeling, analysis, and control. And so right from day one, because of DuPont and that experience in the postdoc, I was able to begin this bifurcation of my lab into both process systems and biological systems.
Frank, I asked about the cultural impact of your time at Cambridge. Purdue being a very large university in the Midwest, very different from your earlier experiences. What was the value of that for you?
I have only the fondest memories of living in West Lafayette, Indiana. I think to this date, I have never been in a place that was safer, more wholesome, more just family friendly. It was an amazing place. Now, at the time, my wife and I were newlywed. We didn't have kids right away. So the family friendly part wasn't necessarily something that we were taking advantage of yet. But it really was a place where collegiality was such a strong suit in the faculty there. And I think that is a lesson, a principle I've taken with me through my career. But I learned from some of the most wonderful collegial, collaborative faculty there. And that was the long-term cultural influence. I certainly enjoyed things like Big Ten sports, so we took advantage of that cultural dimension of being at a Big Ten campus. And as I think back on my trajectory, my career, I haven't been on a campus that had such a, let's say, sports powerhouse setting. So that was enjoyable. My wife and I enjoyed going to basketball games and things like that. So it was a very good phase of our career.
Now, your connections at DuPont, did that play a role in your decision to move to the University of Delaware subsequently?
I think there was a little bit of DuPont, but there was a whole lot of going back home. Mm-hmm. So I was literally back in my hometown, stone's throw from where my parents were. By that time, we did have two children. And so the idea of being close to family was important. And we recognized that I'm an East Coaster. I've got family in Delaware. My wife is a California girl. She's got family around Palm Springs. The Midwest was neither East or West. And, some would say a compromise. I've often said it was unfortunately a compromise where neither side was happy. So that I think personally, it was good to be near family. I knew Delaware. I knew the University of Delaware very well. And in my field, they were a top 5 program. So this was really going to an incredibly strong campus that I knew very well in a community that I grew up in. It was both reputationally a strong move and personally and culturally the right move.
I know today there's so many exciting interdisciplinary initiatives around chemical engineering at the University of Delaware. Was that already in train when you joined the faculty in the late 90s?
Certainly there were strong centers within chemical engineering. So there was a catalysis center, there was a thermodynamics center. I think a lot of the later developments happened after I left. So some of the great work that they're doing in biological engineering came later. So I think I was there perhaps a little too early to see the genesis of some of those new initiatives. It was a bit more traditional chemical engineering strengths or chemical engineering and chemistry strengths being played out because of the background with DuPont right there in the backyard. And of course, having DuPont meant that we had a veritable portfolio of adjunct faculty who would come in and teach. So on paper, we might be 15 to 20 faculty at the University of Delaware. In practice, we were closer to 30 plus faculty because of the adjuncts from DuPont that we took advantage of. So that was a big part of the character of the program, and I believe still is the nature of the program there.
In what would become a theme for you, moving operations, what did you learn from that experience in terms of research groups, graduate students, things that you wanted to work on? What's important to take with you, and where's there opportunity for new directions at a new institute?
Yeah, I think the skew in my group had already begun to tilt towards biology as the more dominant thrust, if you will. At that point, we had already had some grants to work on the diabetes problem in particular. We did not have local expertise, so not in the Delaware region did we have people like-minded doctors or bioengineers working on diabetes. So we're still doing this in the vacuum of chemical engineers working on the computer doing simulations. So certainly there was some hunger for that, to be in a place where there might be opportunities. But I would say that, what I remember quite fondly about Delaware was and now as a dean myself, was the challenges in managing university leadership, let's say at the dean level, in a place where you have such competing forces. So chemical engineering had a long storied tradition at Delaware, but the dean of engineering couldn't play favorites. The dean of engineering had to really think about, how do we invest in the next things that are coming up without endangering and sustaining the strengths that we have. And the dean at the time, who eventually became university president and is now on his second stint at another university, Eric Kaler, was very effective in that. So he was a chemical engineer. So of course, units outside of Chemie were skeptical that he would play favorites. But he was so even-handed and balanced that at times chemical engineering complained that he was ignoring us. And I remember reflecting as a junior faculty member, I think he's got the balance right. Right? Because we were feeling like we weren't getting enough attention. They felt like he was paying all the attention to us. He had struck a compromise of sorts. And for me, again, way before I immersed into any leadership roles, it gave me a lens into thinking about those challenges of managing competing priorities, of priorities within a constrained resource management environment. And it was a preview of things that I eventually got to practice myself.
I can't help but ask, as you explained, your wife is a California girl. The move from the Midwest to the East Coast was prompted by family. Did that at all influence your decision to join the faculty at Santa Barbara?
Oh, without a doubt. So we both remember the story fondly that there was a meeting of the Professional Society for Chemical Engineers, the AICHE, and Santa Barbara had posted that they had an endowed professorship, the Mellichamp Chair, that they were recruiting to, and it was specifically in process control in my field. And I hadn't said anything to my wife yet about this opening. I had seen it, that it was posted, and I thought I just want to turn it over in my head. And we wound up at this AICHE meeting, and some colleagues from UCSB pulled my wife aside and said, do you see yourself moving back to California one day? And she said, oh, yes, of course. They said, well, we have this opening. So that night in the hotel room, she said, so UCSB has an opening. Did you know about this? And I had to say, yes, I was giving it a little bit of time to think about. So certainly was a factor that here was, again, another impressive place, a place that, the vectors were all across the units on the campus pointed in an upward direction. Powerful leadership. The chancellor now at UC Santa Barbara was my dean at Purdue. So Henry Yang hired me to my first job back in 1992 as dean. And now he's the chancellor of the entire university. And I would say career-wise, a big piece of this was the endowed professorship. So, at a place like Delaware, I think we had one, maybe two in the entire engineering college. And likewise, at the time at Santa Barbara, there were only a couple countable on one hand. So the idea that at this early stage of my career that I might be considered for something like a, chaired professorship was very attractive. And then as I got to meet people and learn from colleagues there, the interdisciplinary environment, so that theme is coming up again. I think Santa Barbara, more than any other place at the time, had sort of cracked the nut on how to do this in a very effective way. And I got a preview of that as they were recruiting me. And I thought this could be an exciting place to have our work kind of advance to the next level.
Frank, was the biotechnology revolution really underway, especially in California, by the time you joined the faculty at Santa Barbara?
It was, and there were very strong ties with folks at UCSB who had been involved in founding some of the big California biotechs. The life science side of UCSB was very powerful. UCSB, mind you, did not have a medical school. So while they did have these strong biotech strengths, they were anchored in places like the chemistry department, the biology department, the chemical engineering department. But it certainly was underway and was a big part of, I believe, what enabled us to be competitive in that center that I talked about that we got involved in, that was the Institute for Collaborative Biotechnologies.
Now, did you come to Santa Barbara with administrative leadership responsibilities from the beginning, or that grew over time?
No, that really was my first experience, was at UCSB. So I'll never forget, very fond memory of a Saturday working session where the two deans, the science dean and the engineering dean, called a handful of faculty, maybe 10 of us together. And this was my first year, I believe, at UCSB, because there had been a call for a proposal for this Institute for Collaborative Biotechnologies. It was a massive, massive grant, something like a couple $100 million over 5 years, very sizable center. And I can remember sitting around the table, Saturday morning when most people were out at their kids' soccer game or doing things like that. But we were all so inspired and excited about this unique opportunity. And one by one around the table, people were saying, "Oh, we've got the team. This is the expertise. We could do this." And I remember Alan Heeger, Nobel laureate, reading the document, said, we need systems and control as a part of this. And I raised my hand and I said, UCSB has one of the most powerful systems control programs in double E and mechanical and chemical. I was the new young guy that didn't know this person. And he pointed at me and said, "Great, you're going to write that section." And so I wound up playing a pretty serious role in the drafting and writing of this. I got recruited right away to be the co-director. So my good friend Dan Morse was leading this charge, but he drew me in as a partner really through this process of pulling together the grant. And so when we did get the award, I was the inaugural co-director of the Institute for Collaborative Biotechnologies, and kind of baptism by fire, got thrust into leadership administration by virtue of that institute.
Now, was the Institute originally designed to be Santa Barbara only, or was it always going to be collaborative with other universities?
It was from the get-go going to be collaborative. The only piece that changed about halfway through the RFA window, they modified the language. It originally had a biomedical focus. And so we were looking around for medical school partners because, as I said, UCSB did not have a medical school. But then the Army rewrote the language to make it more biotechnological in focus. And that's when we said, boy, we've got these collaborators and friends at Caltech, collaborators and friends at MIT. This is the dream team. Let's pull this together. And indeed, we wound up getting that grant. And it, to this day, is still running and is still funded. So it's a very powerful and sustainable funding cycle.
In terms of size, in terms of geography, of course, Santa Barbara, MIT, Caltech, very different schools. In what ways is that collaboration evocative of the sum being greater than its parts?
That really is an apt metaphor for this because geography did not get in the way. There were a lot of us who were concerned about that. Mind you, this is pre-Zoom. So this is before we were all very comfortable and versant in long distance information exchange. But we had enough ties, and reason Caltech was easy, that was just 2 hours down the road. But with MIT, enough reason to have their faculty coming back and forth, have our faculty going out. And it became, at the end of the day, I think we had 60 plus faculty across the three campuses. At UCSB in particular, we had every single engineering department represented, every single science department represented, and a handful of the social science departments were getting funded from this activity as well. So the sort of breadth of science and engineering going on across these three powerful campuses was really exciting. And it gave me a chance to reconnect with John Doyle. So he was one of the performers from the Caltech side. By this time, my primary mentor, Manfred Murari, had moved to ETH. But John, of course, was at Caltech, and he had likewise taken a pivot to get into biology. So it was a perfect connection to pull John and people like Richard Murray, Francis Arnold, Dave Terrell, a host of powerful collaborators in Caltech to join this team.
Given the span of the Institute, all of the things that it was involved in, what were some of the unifying themes in terms of its mission, in terms of what it wanted to accomplish?
Yeah, I half joking, but really half seriously say that if you boiled it down into three words, it was sense and respond. Sense in the domain of thinking about sensors, ways to measure things that were going on. Respond being actuation, whether it was at the micro scale or the macro scale. And in many ways, that humble little conjunction and was what people like me worked on. We connected, we did the feedback, we did the automation and linked sensing and actuation. But it really was an institute about understanding sense and respond mechanisms, principles in nature. It had a strong element of reverse engineering, which harkened back to my DuPont days. And the whole reason that I got into working on biology was to, mine and explore what Mother Nature had done and find ways of bringing that over into the engineering realm. And it took me in directions that I really never expected. Early in our conversation, we talked about circadian rhythms, thinking about that as foundational work, right? Pushing frontiers of understanding. Well, under the aegis of the ICB, the Institute, we took our circadian rhythms work and went from an algorithm that the neurons in the brain were using to synchronize their activity to come up with a timekeeping mechanism for acoustic sensors that could be used in the context of localizing noise sources with a precision that had never before been achieved. And so we ran the full spectrum from here's our fundamental understanding of neurons communicating and interacting to here's a device that we field tested at a firing range, actually in near Natick, Massachusetts, Fort Devens, tested this algorithm for doing source localization by having synchronized sensors. So it was just a remarkable array of activities.
Frank, when in the narrative do you get named Associate Dean for Research at UC Santa Barbara?
So that happened, probably midway through. I was 13 years at UCSB. About midway through, I had been tempted by another school to go take up a deanship. And the allure of being a dean, the opportunity was intriguing, but the circumstances weren't a perfect fit in this case with this other campus. But my dean back at UCSB, Matt Terrell, recognized that I had this appetite and I think aptitude, and said, Frank, I can get you involved here in leadership. We can do things in the College of Engineering. I'll appoint you as an associate dean for research. And so I concurrently was both the director of the Institute for Collaborative Biotechnologies and working with Matt in the College of Engineering as its dean for research, associate dean for research, working on really initiatives in biomedical engineering and bio. So we had a new building project, which really proved to be a preview of future attractions for me as dean here at Harvard. We had a new PhD program, again, ditto, preview of future attractions. So it whet my appetite around a couple of higher level administrative responsibilities and opportunities. But it was really the mentorship and support of Matt Terrell at the time that kind of pulled me into that role.
Now, being dual-hatted and all the time keeping up your own active research agenda, your own graduate students, just a time management question. How did you keep all the balls in the air?
Well, just to make your question even more compelling, 2 years before I left UCSB, I added a third hat. So I became the chair of chemical engineering in my department. After many, many years of deans asking me to be a department chair, I finally succumbed, but I didn't let go of the other things because I was convinced I could somehow do the time management. Um, and I would say that it's part ruthless efficiency. You've got to be really practical with appointments and schedules. I think there's a intentionality to how you schedule and manage your time. So I've never been a fan of meetings for meetings' sake. And this was a period of time where I really honed that skill, where if we were going to get together a group of important people whose time was valuable, we were going to have a purpose, an objective. We were going to get to conclusions. And that's why we would convene together as a group. So it really became a chance for me to focus some of those skills and sharpen skills. I'd say there were some things that were sacrifices and all that. So I wasn't necessarily a person who would hang around at the water cooler or the coffee pot, but I feel like I had less time to just kind of hang out in the hallways and kibitz with colleagues, which had been enjoyable. So I was kind of on the move and doing multiple things. I also had this maddening setup, as I reflect on it now, where I had 3 different offices. And so that was also part of this efficiency of I could be embedded, even if it was a day a week or 2 days a week, with the part of the organization that I had some responsibility, and then shift. And the next day or two, I was embedded in the other part and then shift again, so that it wasn't every day juggling the 3 different balls, but really taking a day or 2 of the week, focusing deeply on one of the activities, shift, take another day or 2, focus on the other activity.
Frank, when the opportunity at Harvard came up, I'm curious, were you happy at Santa Barbara? Could you have envisioned yourself staying there for the duration? Was there enough room for your own growth on campus at Santa Barbara?
Oh, absolutely. My wife and I joke about the fact that we had planned our retirement in Santa Barbara. This is where we were going to live out our days. And it was just the kind of thing where opportunity came knocking. And I think what really opened the door to a conversation was the fact that Harvard was a very special place with a liberal arts foundation, but a burgeoning translational, professional, and engineering portfolio of schools. I did my undergraduate degree in a liberal arts institution, which I always felt was the critical foundation to those of us who even went into science and tech to have not only competency and skills, softer skills at times, but also awareness of context, of understanding why we're doing tech, not just how to do the tech, but why we're doing it or when we shouldn't do it. And so there was something about getting back to my roots, getting back to a liberal arts institution after 3 different campuses that were public schools, to be able to get back into the private school domain and have that experience. And I'll say that the other piece of it was the growth potential at Harvard. It was a chance to come in and take a program and literally just, double the student body, grow a new building, have incredible resourcing to accomplish these things. It wasn't something I was looking for, something I in any way expected. And I even challenged the person who was leading the search committee. I said, I've only been a department chair for 2 years at UCSB. Do you think I'm ready for this? And they pointed out, as I've shared with you, that I ran this big institute for 13 years. And so that was the experience that they were drawing upon.
Frank, coming to Harvard, it's a big university, it's a big school. What was important for you to wrap your head around from day one?
Yeah, I think the thing that almost had me reconsidering was the fact that up and down the West Coast, my colleagues to a T were all saying to me, oh, at Harvard, everything's siloed. The med school doesn't interact with the engineering school. The business school doesn't talk to the engineering school. You're not going to get to know these other deans. And that really gave me pause for thought before I went there. So I really endeavored to want to be a collaborator, a connector in that ecosystem. And I had the marvelous good fortune, it was a big part of my accepting the opportunity, that the president at the time, Drew Faust, had really come in with a mission, almost a mandate, to create one Harvard. And that was her moniker, one Harvard, that the whole could be so much more than the sum of the parts if the schools could work more closely together. And I have to say, literally, the first couple of months I was on the campus, the school deans of every single school at Harvard showed up in my office. And that really confirmed for me that these were myths, these were, legacy reputational issues and not the Harvard of today. And so literally every single dean, and when I tell that story, a lot of people will say, wait a minute, the divinity school? And I'll say, yes, David showed up, and David and I are big soccer fans. We talked football for a while, but then we really talked about ethics and engineering and technology and policy. And with every dean, there was an opportunity. And I'm humbled that the presidents I got to work for used descriptors like, well, Frank Doyle in the engineering school, they're the bridge builders of Harvard. That's what Drew Faust used to call us. And Larry Bacow, the president who's about to step down, called us the connective tissue of Harvard, which I thought were just these amazingly evocative and powerful metaphors to describe the role that engineering really was, making connections and doing translation, and not in an egocentric sense, but really was central to connecting so many parts of the Harvard ecosystem.
Now, when you joined Harvard, had John Paulson already endowed the school and the deanship, or that happened under your watch?
It happened concurrently. So as I was being recruited, the they kept hidden from me the fact that there was this recruitment of a big gift happening in the background. And I can remember that after I accepted the job, but before I started, I got a phone call from the dean of the faculty at Harvard, Mike Smith. And he said, Frank, we'd like you to come out. There's this event with a donor. We'd like you to be out here for that. That donor is going to make a nice gift. Literally, those are the words he used, a nice gift. And I remember that we were having something with the Biotech Center back in Santa Barbara, and we were bringing in a lot of high-level delegates. I think the governor and folks from Washington were going to come out. We were going to host them the same week. And I said, oh, Mike, I really can't. I've got this big event, and this is my finale here at UCSB. I've really got to do this. He goes, Frank, I need to tell you a little more about the gift. It's a $400 million gift for you as the dean of the engineering school. And I said, Mike, I will book my ticket. So it was, in a way, a signing bonus that, the likes of which I could never have imagined.
Did you have an opportunity to interact at all with John Paulson, get to understand what makes him tick?
Oh, quite a bit. He's an incredibly intelligent, curious individual. We would cross multiple times a year. I'd go down to New York and visit him. He would come to campus. We would arrange lab tours and panel discussions with my faculty. And I have to say, there are times when you do this with even really bright people, and they kind of go through the motions. They nod and smile when you give them a lab tour. But John was very inquisitive and was always probing and asking really, spot on, insightful questions about the work that was happening, whether it was in the realm of quantum science and engineering, the realm of synthetic biology, the realm of AI. So I really, really enjoyed my interactions with John, and quite literally, his was the first phone call I made after I accepted the position that I'm headed to next at Brown, to say how much I had enjoyed our interactions, and the place would be in good shape, but I really appreciated his trust and investment in the program.
This obviously is a very good problem for you to inherit right from day one. How do you deploy those funds? What were your considerations?
Yeah, so we did a number of faculty brainstorming sessions to get a read on some growth opportunities and research, to understand on the teaching side of the house, the academic programs, where there were pain points and where there were needs. So really it was a very consultative process that we had there. I had come from a campus, UCSB, where the faculty senate was incredibly powerful. So really they were a strong voice in governance. And so the idea of faculty governance, while it wasn't codified as such at Harvard, there was a strong sense of the faculty voice was important. And so convenings and conversations, listening tours, talking to people, trying to identify the priorities. And in many ways, I felt my job was to listen and to react to and to help support and enable. but really it was the dreams and the vision and the aspiration of the faculty that it was my job to support and enable. And that's how we would deploy the resources.
Frank, do you think you came in with a mandate, or was it your own personal interest to see opportunities at Harvard to enhance an entrepreneurial spirit, to build bridges with industry?
You know, I did not come in with that as a mandate. And I will say that at times that had proven challenging in my 8 years there. She was an amazing, absolutely amazing leader, Drew Faust, but she would playfully and provocatively at times challenge me about what is the nature of the partnerships we're trying to build? Why are you pulling industry closer? Because I think there was still, particularly in an institution like Harvard, an Ivy League institution, a liberal arts-based institution, some doubts about the role of the private sector. And would that taint or interfere with the academic mission? And Drew and I had some really thoughtful conversations about the fact that that's exactly why we need to pull them closer as partners, the private sector. In engineering, we solve problems. Where do those problems come from? The real world. The folks who are working on those problems can both be teachers in the classroom, can be providers of case studies and challenge problems and data sets. They can challenge our faculty to think about new directions for their work. And so we really came to this understanding that it was exactly for the academic mission. And yes, there would be other, ancillary benefits, including sponsored research, but that it was the nature of engineers and applied scientists that we needed those strong ties. And so it really was more of a personal quest here to bring that. And I think entrepreneurship, likewise, was not something that was second nature at a place like Harvard. I think there was a lot of, oh, that's what Stanford does, or that's what MIT does. That's not in the DNA of our faculty and students here. And really, with a lot of great partners, including the dean of the business school, we were able to pull together programs that showed that the skills in innovation might serve the entrepreneur, but those same skills serve the leader of a venture within a larger company. Those same skills serve an academic who's leading a research group. All the issues around communications and marketing and branding and team management, those are common skills across a number of different career paths. And so making it clear that this wasn't about, oh, we're trying to promote the kids have their big blockbuster idea and they quit school their junior year and they go to a startup. That wasn't what we were advocating. We were really talking about this as a set of skills to complement their fundamental training and a discipline that they might use then as they launch into their careers. And I think we were very successful. We brought in some nice gifts to enable new programs, degree programs, hiring positions. Right as I was leaving, and this is one of my great regrets in leaving, is I started an initiative called the GRID, G-R-I-D, not an acronym, but really a metaphor for undergirding, for infrastructure, for entrepreneurship. And so we're just launching this program at our new campus in Alston, and I'm going to get to watch from down the road them succeed and flourish.
Frank, moving our conversation right to the present, a challenge we've all dealt with. When COVID hit as dean, what was most important for you in this crisis atmosphere?
Yeah, I think first and foremost, of course, is safety. So we had to think about the safety of our faculty, of our students, of our staff, of our facilities. I think being at a place like Harvard is a bit of a double-edged sword, because on one hand, we had the wealth of medical expertise in the form of the medical school and the School of Public Health. Even our provost is a public health expert. So we have this wealth of in-house expertise. But the sort of challenging part of things, as I came to learn over my years in leadership there, is how much Harvard sets a tone for many other campuses. So folks look to Harvard to see, oh, well, what's Harvard doing? We should follow. Or maybe they say, what's Harvard doing? We should go the other way. But there really is this pressure of a decision we make isn't just about us, but it's going to have a ripple in the community, because people will assume, oh, if the engineering dean at Harvard did this, he must have talked to the medical school dean, and consequently, this has the power of that knowledge base behind it. So I think there was, there were rapid meetings right away. The leadership sprung into action. It was a deeply collaborative leadership endeavor at Harvard. But I will say, in my career to date, the hardest decision I have ever made was to shut the labs down. And I'll never forget the date. It was March 18th, my birthday in 2020, that a few days before we came to the conclusion that we had to shut the labs. This was as you posed the question originally, what was first and foremost safety. But our other big peers had not yet shut their labs. And so we're looking around the country saying, oh boy, we're going to be one of, if not the first of the major research universities to say, we're closing the labs. This is the prudent thing to do. And of course, within hours and days, lots of other places were right in line to do the same thing. So we felt assured by that, or reassured. But that was a tough leadership decision.
The forced laboratory experiment of higher education done remotely. Now, hopefully, finally, if we're beyond the pandemic, is there anything from that experience that was good that's worth taking with us into the future?
Oh, without a doubt. I think all of us have learned how to use online modalities to not only enhance the traditional classroom experience through office hours, help sessions, asynchronous content that can be pulled up later. But many of us have realized the opportunities in offering curricular elements, whether it's executive education, certificate programs, whether it's K through 12 outreach. We now have tools and modality that everybody's comfortable with, right? That baptism by fire into using Zoom and other tools have all of us as experts now. And really the reticence that people might have had pre-COVID about doing online teaching, virtually nobody has that anymore. So I think there are powerful lessons we're all taking forward.
Frank, to go back into reflective mode and to round out this terrific conversation, of course, the work is never done, but in thinking of your service as dean, what aspects of the job do you feel you really came in and completed, and what aspects are stepping stones for your successor to build upon?
Yeah, I'm going to pick two of my peer deans to answer those two parts of your question. So the part I think we did quite effectively was cemented a relationship with the Harvard Business School. And I had the just amazingly fortuitous experience that when I was hired, the dean at the time was a fellow chemical engineer. So right away, as he likes to say, we had chemistry together, right? We bonded, but we did. And we were like-minded and had, great ideas about how to pull the faculty together, how to brainstorm programs and methodologies. And he and I built together a joint master's program that I told you about. We built a first of its kind undergraduate program where undergraduates from Harvard could access and be involved in the business school. And then we built the first ever for the engineering school certificate program, a program in business analytics. So many successful joint enterprises between our faculty. And all of this was before we moved the school across the river to be adjacent to the business school. So we basically built up a head of steam of activities that when we became proximal, adjacent, we suddenly had this burst of, accelerating the activities that we had already started. So that one, I think, is sort of a point of pride that we did what we'd really hoped to do. There's more that could be done there, but we've laid an incredible foundation at that partnership. I think, ironically, the one that some stepping stones perhaps are laid down, but there's so much more to do, is with medicine. So here I come in with my own medical interest and background, connect to the medical school with things that we were doing in my lab. But I think there's still more in joint programming, joint studies, joint faculty appointments that could be done. And we have a few exemplars and a few, initial inroads we've made there. I have an incredibly collaborative counterpart, George Daly, the dean of the medical school. My successor, I'm sure, will enjoy a wonderful relationship with George.
Finally, Frank, last question looking to the future. As you embark on this new responsibility at Brown, what aspects of all of your experience do you want to bring with you that give you some preconceived notions of what's necessary? And where do you come in looking at the importance of the blank slate? Really just going in and listening and learning, until you really get your bearings.
Yeah, I think it's a curious mix of the two, as you might expect. And I do need to start with a listening tour to really understand what are the passions, the excitement, the aspirations of the faculty, particularly outside of my comfort zone. So it won't just be the engineers and applied scientists, but now I'll be working with the arts and humanities, with the social scientists, the medical school, school of public health, public policy. So I think that's going to be an exciting piece of this, is the blank slate, as you called it, aspect. But I think perhaps an advantage that I bring to this is the fact that I've been on 4 very different campuses as an educator. I've been trained on 3 very different campuses as a student. So I have the wealth of perspectives, experiences, mechanisms, cultures of those 7 campuses, but most importantly, the 4 that I worked on, that have a range of approaches to faculty governance, that have a range of approaches to institutes and centers, and how you conduct research. And I can really take the lessons I've learned from all those myriad experiences and find out what fits and what's appropriate at Brown as I do the listening tour. So I need to listen and then draw from the toolkit that I've built over my career to find the right connections and solutions to enable things.
Frank, this has been a phenomenal, wide-ranging conversation. Your career is a real point of pride for Caltech, and I want to wish you a lot of luck at Brown. Thank you so much.
David, thank you. I have really enjoyed reminiscing and reflecting here, and I wish you luck with this project.
Thank you.